The first thing which I would like to do will be to give you the proof of your this quotient rule. That is d by if fx and if f1x and f2x are two differentiable functions, it is given. Given is f1x and f2x are two differentiable functions. Are two differentiable functions are two differentiable. Yes, are two differentiable functions. Then you know d by dx of f1x upon f2x is equal to, you know it is numerator and this function is in denominator. So what you do is, you know very well that it is denominator is square and denominator, and derivative of a numerator, that is d by dx of f1x and minus f1x first function into derivative of the this denominator, whatever the function is in denominator. So we will give the proof of this thing here. It's very simple. If see, what is this thing? Let us take the left hand side here. So d by dx of f1x, f2x, that is d by dx of f1x upon f2x. Let us see what it is. See, students, see, things are very simple. At very first instant, you may find a little bit of difficulty, but then I can rest assure you that once you concentrate it repeatedly, then you will get to the bottom of the things. Then see, once you understand these basic definitions, then of course rest of the things will be too clear to you. So this thing, hardly anything difficult. You apply the basic definition of the differentiability. It is what? It will be f1 x plus delta x upon f2 x plus delta x minus f1x upon f2x. Okay, and whole upon delta x. This thing you keep in bracket and limit delta x tends to 0. And please do ask me each and everything. Now here one question which must be coming to your mind is that where I have taken, have I taken differentiability at a point? So if at all it is at a point, then what you will do? Suppose that point is x is equal to x naught. Okay, so one way could be that you can here particularly like if it is differentiability at the point, then you can write here everywhere x naught. X naught. Otherwise, no difference. X can be any point. X can be any point. So if I am writing only students here, and here I will write x is equal to x naught. See, in left hand side, if here this is my function. What is my function? f1x upon f2x. Of course, inherent in here is that f2x is not equal to 0. Or if it is 0, then those points we will ignore. So we have to check it whether the function is differentiable at x is equal to x naught or not. Then see, one thing is that you can write like this, okay, upon delta x. And then see, now if you are, the way I wrote earlier, that is I wrote earlier was f1x plus delta x upon f2x, x plus delta x minus f1x upon f2x. So here see, there x could be any point. There, instead of denoting x to be my particular x is equal to x naught. X naught of course conveys particularly that yes, you one point at point x naught you are checking the differentiability. But no harm. If I am simply writing x also, then it means that the function is differentiable throughout the domain. So do depending upon. So since this is differentiable throughout the domain, that's why I prefer writing x. Okay, so I will do it both the ways. So just now instead let me prove that it is differentiable throughout its domain. Then let us see what we can do. So I will not write x naught. Here it is understood. So context will make you clear. Now, this formula, this is not applicable for one point, it is applicable for all the points in the domain. So, it is always advisable to take the general point x here. Okay, so this is the basic definition. Now, what I can do here, please see. Okay, let me simplify this thing. I will take limit later on. Okay, so what I will get? In LCM, in denominator, I will get fx plus delta x and f2x. And here what I will get is f2x and f1x plus delta x minus f1x into f2x plus delta x. This thing you close within the bracket and upon delta x. So this delta x also let me write over here. Okay. Now see, and then of course limit delta x tends to 0. Now things are easier. Here see, I had to change my numerator, and in what manner I will do it, please see to it. It is to be written like this, that see here what I will do, f2 and then see f1, f2x, okay, and f1 x plus delta x. I want now see, I want the derivative of first what is written in the numerator. So f1 x plus delta. So what I am doing is I am subtracting f2x and f1x here and adding the same quantity here. So both will cancel and it will not make any difference there. See, these two terms will cancel, and then I will copy this last term as such, minus f1x, f2x plus delta x, okay, upon, whole upon, whatever is written here, the denominator, let me copy as such, x plus delta x, f2x and delta x. Close everything and make it limit delta x tends to 0. Now see, from this term and this term, what you can take common? f2x. f2x you can take common. And then what you will get here is, within bracket is f1x plus delta x minus f1x, okay. And then see, this delta x you divide here, this delta x you write here, okay. And then from these two terms what you can do, you can take f1x common, okay, rather take minus f1x common, this thing. I am taking see minus f1x common. So here I will get f2 x plus delta x. This is f2 x plus delta x, and from here what I will get is minus f2x upon delta x I will write here, and then whole upon how much? f2 x plus delta x and f2x. Now see, here in the denominator I am not writing, and then this whole thing here I will be taking as limit delta x tends to 0. How simple the things will come out. See, you will enjoy it. Only a little bit of efforts on your part will make a difference. Now please see, what I will do, this whole thing, I will consider this much of thing to be one function, this to be another function, and limit of the sum of two functions. So first of all, I will invoke limit of numerator upon limit of denominator. And then after that, I will, the numerator, this much of entity I will take to be one thing, and this much of entity I will take to be the another function. So limit of the sum of two functions is equal to sum of the individual limits. So eventually what you will get is, okay, I will write on the top so that you can see the things clearly. Okay, I am writing all these things. Okay. Here. Now from here, I am jumping here. So what I am getting is now limit here. So first of all, limit of this whole numerator upon limit of denominator. So limit of numerator I will, and upon limit of denominator. Limit of denominator is limit delta x tends to 0, f2 x plus delta x, and into limit delta x tends to 0, f2x. Okay, and here see, this much of limit I will take, and this is the product of two functions. Please see, first of all, this will be the limit of this thing minus limit of this thing. then this thing is the product of two functions, this and this whole thing written. Likewise, this is also product of two functions. So limit of product of two functions will eventually turn out to be the product of their individual limit. So effectively what I will get is that it is limit first this much of thing. Okay, I will not rush f2x, and within bracket is f1 limit of f1 x plus delta x minus fx upon delta x. Okay, this thing minus big bracket here, and then limit of this whole thing. And limit of numerator is what? Limit of this minus limit of this. So it is what? Limit delta x tends to 0 f1 x, and then within bracket is what? f2 x plus delta x minus f2 x upon delta x. And then okay, now see this limit, this is the product of two functions. Likewise, this is the product of two functions. So eventually what you will get is limit f2x delta x tends to 0 into limit delta x tends to 0 f1 x plus delta x minus fx upon delta x minus. Likewise, this limit is the product of two functions, delta x tends to 0 f1x into limit delta x tends to 0, and this whole thing x plus delta x minus f2x upon delta x. Okay, and then whole upon numerator here, this limit is what? f2x plus delta x. Now see, given to you is this f2x is differentiable. A differentiable function is always continuous. So limit of delta x tends to 0 is nothing but f2x. See this limit is what? f2x. So and this is what? Independent of delta x. So here it will be again f2x. Now see, now we have got our answer. If you look in, so what it is now? Limit delta x tends to 0 f2x. See here nowhere delta x is coming, so this will be f2x only, and this whole thing is what? Please limit this thing. This is the derivative of f1x of the function given in the numerator minus limit first function. It is likewise limit delta x tending to 0 f1x. f1x is a function of x. Nowhere it is depending on delta x, so it will be as such f1x. And this thing is nothing but d by dx of f2x upon this is f2x into f2x, that is f2x whole square. And this is how you remember it. Please see, it is like d by dx of a function, numerator upon denominator. You know it is denominator is square, and then a denominator into derivative of numerator minus numerator into derivative of denominator. This is a way to remember this formula. Now with this proof, now we will come to our main theorem of the today, which you like to do it, and that is the derivative of the composite functions. See, okay, that article I will take in last. Today we will take up two more new things of class 12, and that will be the derivative of the composite functions and derivative of the implicit functions. Okay, so derivative of composite functions. This is a very important article, and this derivative of a composite function. Composite function or function of function. Composite function or function of function, whatever you feel like, may write it. Or function of function. Function of function. Okay, so effectively what you are finding is d by dx of gfx. Gfx. Now, first, before we proceed here, Few things I would like to make it clear at the outset. Here, fx is the internal function, gx is the external function. And moreover, this function, internal function, is differentiable everywhere in its domain. Everywhere in its domain. Internal function will be having a different domain, external function will be having a different domain. So both external and internal function, that is given, that they are differentiable within their respective domains. So this is what is given, and then we are proving the result. So what it will be? Very simple. It will be limit from the fundamental definition. Delta x tends to 0. So, but here see, before you write this thing, you write what is given. Given is both f1x and f2x are differentiable in their respective domains. This is important. Okay, now with this understanding we can do it. Limit, and now you will invoke your fundamental definition. Limit delta x tends to 0 what? G f x plus delta x minus g f x upon delta x. This thing you write well within the brackets. Okay. I think it is clear in both the places. So now what it is, that this thing, let us see how we are going to write. Here see, put internal function is equal, internal function, what is your internal function there? fx as t. So t is equal to fx. Now see, t is equal to fx. So what will be fx plus delta x equal to? This thing you need to know it. Now we have said that this internal function is differentiable. Yesterday we did a theorem, if a function is differentiable then it is continuous. Okay, now since it is continuous everywhere in its domain, so if you are making a slight change in this thing, so it will change to t plus delta t, where when delta x tends to 0, then delta t also tends to 0, because function is continuous. Because you write it, because BCS, because fx is continuous. Why continuous? Because it is differentiable. A differentiable function is always continuous. Okay, so that's why it's continuous, and therefore we are justified in writing like this. So this equation 1 becomes what? So 1 becomes now, please see, it becomes gt plus delta t. And at place of fx plus delta x, from here, what we can write? T plus delta t minus gt upon delta x, okay, and then limit delta x tends to 0. Now this thing we will further write like this. Please see, limit, I will replace my this thing, z t plus delta t minus gt upon delta t I am dividing, delta t I am multiplying upon delta x I am writing. Okay, and this thing I will write as the product of two things, and the limit of this whole will be equal to this thing. Please see, delta t will cancel. So effectively you are getting gt plus delta t minus gt upon delta x. See, this delta t will cancel. Now this is the product of limit what? Limit, you can well write delta x tends to 0. Now here see what you will write. Limit delta x tends to 0, because limit of the product of two functions is equal to their product of their individual limits. So you are safe in writing gt plus delta t minus gt upon delta t into limit. And here delta t, let us put the value of delta t from here. T t plus delta t is this thing, t is this thing. So here delta t will be what? Delta t will be fx plus delta x minus t, and t is fx. So at place of delta t, what we will write? Fx plus delta x minus fx upon delta x. Okay, and then the delta x tends to 0. Okay, now see here. This thing is what? Either you write delta x tends to 0 or you write delta t tends to 0, because this point we have already seen. When delta x tends to 0, then delta t tends to 0 or delta t tends. So here see, in fact, what is happening? Delta x tends to 0 implies delta t tends to 0, and delta t tends to 0 implies delta x tends to 0. Please see, from here it's simple. I've already explained you why such a thing is happening, because your function is a continuous function, and in continuity, if delta x tends to 0, then what will happen? This fx plus delta x will approach where? Fx, and fx is what? T. So delta t will also tend towards 0. So this here, instead of this thing, I will write now limit at place of delta x. I am justified in substituting here as delta t tends to 0. And this is gt plus delta t minus gt upon delta t, and limit, this limit is what? This is f dash x. This is d by dx of fx. This is d by dx of fx. Please see, this internal function. F is your internal function. And then see what it is. This thing is g dash d by dt of gt. Please see, and d by dx of fx. So this is your composite formula, derivative of this function of function. This is this formula. And what this formula says, please see this thing. It is, see, first of all, what you will do. You will, now please students, from this formula, let us understand it. What you will do, you will first of all put the internal function equal to t. And then you will differentiate this external function with respect to internal function. Please see, d by dt gt, what does it mean? It simply means that you are differentiating external function g with respect to internal function t. T is your internal function fx. Please see, t you have assumed to be your internal function. So this first thing is very important, and then you take its product with by differentiating the internal function with respect to the independent variable x. So this is what you have to do it in question, and then see, you can do all the questions very simply. In a very simple manner. Only what you have to remember is that first of all, whatever the internal function is, that you put equal to t, and then you differentiate the external function with respect to internal function, d by dt of gt. G is your external function, t you have assumed to be your internal function, and then you will take its product by differentiating the internal function with respect to independent variable. These two are very important, and this is what the formula is for differentiating function of function or composition of two functions. So this is what we will take up your exercise here, and students, please remember that see, many of you must be having aspirations of qualifying some good competitive examination, and you must be taking coachings also from Kota and so many places, Fiji and all that. But remember that unless and until you have not prepared the theory and the questions of your NCERT, then you will be in real trouble. So your expectation will totally get belied. You will think that something very difficult is being taught over there. They are teaching something very complicated. No, it is not like that. I can well assure you, these are the basics. If your basics are clear, then only see the questions which these people do in these Fidjis and all these things, they are certain tricky questions. But unless until you don't understand it like this, the basic theory, see, you will be always on a very shaky wicket. My request to all my students is that please be truthful to the core of your heart. Anything which you don't understand, whether in coaching or anywhere, please do ask it. Fundamentally, your NCERT book should be, on the tip of your tongues, and once this thing is there, then of course, see, these coaching becomes more useful, because they give you
exposure to those tricky types of questions which of course had. But to understand these tricky questions, of course, remember that these fundamental theory and the fundamental concepts should be very much clear to you. And that, of course, there you need to visit your this NCERT time and then. Okay, all the formulas, and that is what we are ensuring it, that our students should not be on the shaky visit. And then see, at times you will be talking about so many things that we have done it from this. Don't think it. Everybody are, absolutely blank, because these are the things which you have been using elsewhere also. You finish right from class 11 without knowing what actual differentiation is. So with all that, we will take the questions here so that you understand the things comprehensively and in a more determined and useful manner. Yes. Now take first this exercise I am taking here. This is better also known as chain rule. So very simple. First I will take very simple questions. Like first question is sine x square plus 5. Now how you will do it? At times you will think yourself that you will be skipping the step, you will be doing it directly. But no. My request to all of you is that first of all, do write everything stepwise. So what you will do? Put t. What is the external function here? Sine x is the external function, internal function is x square plus 5. So t is, so put t is equal to x square plus 5. And t is what? Internal function. T is your internal function. See, first initially when you are doing the things, then you write everything in detail. And you need to know that this is the composition of two functions. X square plus 5 is the internal function. So what it becomes? D by dx of sine t. And then see, by chain rule, this becomes what? D by dt of sine t and dt by dx. dt. So what you will do? External function you will be differentiating with respect to internal function into this thing. And then see, d by dt, at place you will write cos t, and dt by dx you will differentiate here. dt by dx here will be 2x. That all. So this value you write here, and here you can well write cos, and t you can put here as x square plus 5 into 2x. So this is how you will be doing it. Now whether you have any complicated question, I will take few complicated questions also, and then you will see how things will be coming here. First give me exposure. This is question 1, question 2, because many of you must have not been doing it. You have to differentiate cos sin x. Cos sin x. See, once you get adapted to the things, you will very simply be writing it. External function minus sin x into then internal function cos x. Already you will be writing, but no, in examination you have step marking, so please be cautious. So first of all, what is internal function? So here you put t is equal to sin x. Write down t is internal function. T is internal function. Please develop this practice, because reasoning is more important, and that this reasoning provides you the confidence. And when you reason it out, then see this becomes d by dx of cos of t. Cos of t. Okay. Then by chain rule, what it becomes? D by dt. External function is cos. So external function you will be differentiating with respect to internal function d by dt of cos of t, and then dt by dx. dt by dx. I will take a cos t is what? Cos t is minus sin t, and dt by dx. T is sin x, so dt by dx you will calculate here. It is cos x. This value you will put here, so it is cos x. And then eventually you will put the value of t. T is what? T you have put sin x. So it is sin x and cos x. This is how you will do it in your examination. This is how you will do it in the examination. Now see, if I give you any first step by step we will proceed, so that you will have no difficulty in doing any complicated question whatsoever as far as this function of function is concerned. This derivative, later on you will realize. But see, you are a student. At times you will be nervous also. And nervousness comes only when you are not being able to justify, yes, that's how this step is coming. Be very systematic. Mathematics is, at each step there is a proper reasoning for it. And that you need to understand. Yes. Now I will take the fourth question because it involves 3. Sec d by dx, you have to find it. Sec tan root x. It is the composition of 3 functions. The most innermost is root x, then it is tan x, and then it is sec x, outermost. So what you will do? First of all, see this this entire tan root x, you will put t, at the first step. So what you will do? Put t is equal to tan root x. You, instead of taking it to be the composition of 3 functions, better assume it to be the composition of 2 functions. Sec x is the outermost, and the rest of all the thing you take it to be your internal function. Because here we had to apply this rule twice. Now see how. So what you have done, you have put p is equal to tan root x. Okay. So this becomes your what? D by dx sec of t. Sec of t. Okay. Then what it will become? D by, you will write by chain rule sec t, and then dt by dx. Dt by dx. Okay. What is this sec t? Sec t is sec t tan t. Tan t. And dt by dx you will calculate from where? Here. So dt by, now for calculating dt by dx, see again what you have to do. I will tell you. Dt by dx is equal to d by dx of tan root x. Okay. Now please see. Here again it is a function of function. It is again here it is a function of function. So what you need to do is, here see, you will put root p is equal to root x. P is equal to root x. So this thing here will become what? Dt by dx. Please see here. Dt by dx will become d by dx of tan p. Please see. At place of root x, what you will write? P. So it will become this thing. And this thing again by this root, it will become d by dp of tan p into dp by dx. Into dp by dx. Tangent of tan p is what? Tan x is sec square p. And dp by dx you will calculate from where? dp by dx you will calculate from here. Root x raised to power. What it is? 1 by 2 root x. What formula? X to power n. X, this is x to power 1 by 2. So 1 by 2 and x raised to power n minus 1. Half minus half, 1 is minus half. So this will come here. And now you put the value. dp by dx you will put from here. Here. This is say 3. This is say 2. Okay. And in this 2 you will put this value sec square p. And dp by dx is 1 upon 2 root x. Now put the value of p. So put the value of p here. So it is sec square. What is p? P is your root x. So root x 1 upon 2 root x. So this is your dt by dx. So here this is sec t take t, and this whole is sec square root x and 1 upon 2 root x. So this is the derivative, how you will be doing it. This is question number 4. So please see, everything should be explicit. Everything should be explicit. And I tell you, not right now, I will tell you later on that how you can actually do all this business. Very easy. Later on you will learn it verbally. But my request to all the students is that now please see, now we have told you almost the entire theory. Once again I would request you that this trigonometric functions, these inverse trigonometric functions, and then these theorems of the limits and continuity, please do them well, because that will provide you the much needed motivation and confidence for tackling these problems as in the competitive examination. And this is, see, rest here you won't find any difficulty. If you do many questions on this thing, this thing, derivative of this by chain rule, it is not much creditable. What is more creditable is understanding the steps which have been involved therein. Okay, so let us take this thing. Next question here. This was your question number 4, and I will see to it that you are in a position to do all good questions now. Much more complicated. Now question number 5. It is sin ax plus b. Sin ax plus b upon cos cx plus d. Sin ax plus b upon cos cx plus d. Okay. Its derivative you have to determine. This is your function. This is your function. So yes, obviously you can see that it is numerator. One function has been given in numerator, other function has been given in denominator, and in both the functions given in the numerator and denominator respectively are not plain functions. They are simply this thing, function of functions. They are function of functions. So we will invoke the quotient rule. The proof of which we gave you a couple of minutes earlier. So what it will be? It will be denominator is square. So cos square cx plus d, denominator cos cx plus d, and derivative of numerator sin ax plus b minus numerator sin ax plus b and derivative of denominator. Derivative of denominator. Denominator, yes, cx plus d. Okay. So you have come to this thing. So let us see what it becomes. Cos cx plus d. Okay. And derivative of this thing. This derivative we will find here. D by dx of sin ax plus b. And here we will find derivative of the other function, that is cx plus d. So very simple. What here it is a function of function. So what you will do? You will put t is equal to ax plus b. Okay. So it becomes how much? D by dx of sine of t, which is d by t of sine t, and then dt by dx. Now dt by dx, this thing is what? Cos t. Cos t, and dt by dx, from where you will this thing? Dt by dx is what? Ax is what? A. So it is a only. So a cos t is the answer of d by dx of sin a plus b. So here at place of d by dx sin, what we can write is a cos t and minus sin ax plus b. Keep it as such, and then you have to find the derivative of cx plus d. On the same lines, the derivative will turn out to be c. Like ax plus b, it is a, derivative of cs plus b, you can do it, so it will be c. So I am writing it straight away, derivative of this thing, d by dx of cs plus d, I am writing right here, c. You can do it, this entire business, upon what is cos square cx plus d. Cx. So now here, bracket, this one will cancel, okay. So it will be a cos, at place of t, what you will put? Ax plus b, cos t, ax plus b, and one of them will cancel here. This one will cancel upon cos cx plus d, and minus, it is sin ax plus b cos square, and c sin ax plus b, and then this whole denominator cos square cx plus b. So this is the answer. This is the answer. This is how you will be doing it. So hardly anything difficult. Now see, you can try the questions from outside the book also. And I will take this exercise, but once please do ask me if you have any problems or understanding this thing. But then take the easy one. See, there is hardly anything easy or difficult. Only yes, in competition, see, they ask questions based on 2-3 chapter makes, nothing beyond that. And now one question is this thing. Cos x cube sin square x 5. Question 6. Question 6 here. It is cos of x cube into sine square x 5. Sine square x 5. Okay. Sine square x 5. Okay. So sine square x 5 you can well write to be this thing. Okay. Yes. Now this is say y equal to, so dy by dx. Okay, you have to find the derivative of this thing. Dy dx of this thing. Obviously what it is from the product rule. This, you take this to be the first function, this to be the second function. So first function, it is cos x cube, keep it as such, first function, into derivative of what? Second function. Second function is sin x5 is, and whole square. Please see, it is combination of three functions. And then what else? Plus second function, you keep it as such, sin x5 raised to power how much? Square, and d by dx of cos x cube. Okay. Now we will do this thing. Now here first of all we will find derivative of sin x5. This is our one. We will keep the value here. We will take the derivative of cos x cube, and we will take the derivative of sin x this thing, and we will substitute this thing. Okay. So first derivative is d by dx of sin x raised to power 5 square. Now here first it should be clear to you that what is the outermost function, what is the innermost intermediate function, and what is the innermost function. Now I tell you, innermost function is what? X raised to power 5. Intermediate function is what? Sin x. And then outermost function is what? X square. See how I will explain it to you. It is like this. Three combination here. It is f1x is your x raised to power 5. f2x, it is x, y, z, and w. So this eventual function is from x to w. And what are the functions? f2x is what? Sin x. And then it is what? f3x is what? It is combination of x square. So this is all what you need to understand it. How? Because see here x will go where? X will go to x to the power 5. Image of x to the power 5 under sin x will be what? Sin x to the power 5. And the image of sin x raised to the power 5 under this third function will be what? X square. So where x is coming, there you will be putting x to the power 5 and then whole square. So this much of thing you need to understand. This much of thing should be clear to you, and this analysis, see, you can understand it from where? From if you have understood the composition of functions. So this is basically composition of function. Now, as I said, first of course you need, what is your outermost function? X square. Then whole thing, see, you this rest of the thing sin x square, you take it to be t. You take it to be the t here. T is equal to what? Sin x to the power 5 whole square. Now I rub it because you have understood that what is what in the composition of these three functions. And what is the outermost, what is the innermost, so then what is the innermost. So this is now, this will take the shape d by dx of sine of t. See, sin x5 whole square, this whole thing you have, sorry, not like this. This thing here, this thing will become now t square. And because sin x5 is your internal function. Okay, so this thing d by dx of t square you are taking. So this thing you will write what? D by chain rule, d by dt of t square and t upon dx. Okay, this is what? Derivative of this is 2t into dt by dx. dt by dx from here we will calculate from here. dt by dx we will calculate from here. But again here, see, what is the problem? You have, no, it is not a square. Please see, only sin x5 is the internal function. That is why you are getting t square. So sin x5 is the only internal function, so t is this thing. Okay, now again it is a combination of two functions. So what you will do? Here you will put p is equal to x to the power 5 because internal function is x to the power 5 and external function is sin x. So dt by dx is equal to what? D by dx of sine of this thing x to the power 5. Now this is what d by dx of sine of p into, that's all. And this thing again will be written as what? D by dp of d by dp of sine p into dp by dx into dp by dx, because d by dx. And now see, at times you may feel that these two are cancelling. No, please remember, these are not cancelling. It is just a way to remember it. This is one symbol. This d by dx is one symbol. D by dp is one symbol. This is one symbol. So don't take it like it is cancelling. But you can just, for the sake of remembrance, you can understand. But see, dp by dx is what, as a matter of fact, limit delta p upon delta x. Change in the value of p with respect to x thing. Here, of course, see, delta p, limit delta x tends to 0. This dp by dx is well understood like this thing. At times, see, here, if I write delta x upon delta t, and then see, you can cancel here. Here you are justified, but not here, because here d by dp is a symbol. So that aspect will be also clear to you. And dp by dx, how you can calculate from here. It is 5x raised to the power 4. So dp, it is cos p, d by dp of sine p, and dp by dx is value you are putting from here. It is 5x4. Let us put the value of p here. What is p? X to the power 5 into 5x to the power 4. So this value we have determined it, and we are putting dt by dx here is equal to 5 cos x to the power 5 into x to the power 4. And put the value of t also. What is t? T is sin x 5. So 2, okay, I will 2 sin x to the power 5 and how much? T is this thing, and 5 into 10. So 10 cos x to the power 5 and x to the power 4. Okay. So this is the derivative of first part. So this is, this derivative, its value we will take it from here. We will substitute from there, and then the other derivative we will calculate and we will put there in. What is the other derivative? We have to find the value of d by dx of cos of x cube. Cos of x cube. Okay, so what here internal function is this thing. So what you will put p, or say m is equal to x cube. M is equal to x cube. Okay. Now here it is d by dx of cos of m, and x cube you have put m. So d by dx of cos m will be what? D by dm, by chain rule again, cos m into dm by dx. So cos m is what? Minus sin m, and dm by dx you will get from here. It is 3x square. So 3x square, and at base of m what you will put? Sin m. M is how much? Please see, m is x cube. So sin x cube into 3 you will write, let us write here, into x square, into x square. So this is the second derivative. Put their respective values here in 1 and 2. This is your 2. And the first derivative value you will put from here. And the second derivative value you put here this much. So that will be your answer. That will be your answer. So this is how you can do it. I think now whether you have 3, it is a function which is a combination of 3 or 4 or 5 or 6, whatever. And see, first you do these 10 questions of your book, and then we can see, let me see if there is any good question here. Okay, now rest you can do 9 questions, let me do it because it is somewhat different. It says prove that the greatest integer function, okay, defined by fx is equal to itna, is not differentiable at the extreme points. First is modulus function is not differentiable at x is equal to 1. Okay, now question number 9 and 10 I will show you. They are good ones. Regarding modulus function, please see, I would like to tell you, and I request also to you that because before in your book it is given mod s minus 1, I think. You had to show that yes, in question number 9, fx is equal to mod x minus 1, x is not differentiable at x is equal to 1. Okay, it will be, let me have a little bit of water. Yes. here first I will show you that modulus function. It is not differentiable at 0, and at rest of the point it is differentiable. How we will show it? See, you know the graph also. Graph is like this. It is 45 degrees this way, and it is again, oh sorry, it is again 45 degree this way. So it is basically 90 plus 45 this much, and it is 45 this, 45 this thing. Its slope is tangent theta 2 is minus 1 and tangent theta is 1. Okay. Now this point 0, this is function is your modulus function. Now very easy. Modulus function you can write x. If x is greater than equal to 0 or equal to minus x. If x is less than 0. Okay, fine. Now I have to show why. I will show both the ways, geometrically also and through the this your definition of function. Okay, why d by dx of, let us find out this thing. Okay, so what this thing is by definition, it will be d by dx at 0. See what I say, it is not differentiable at 0. So what you will do, it is okay at 0. So I will write later on. I will substitute at place of x 0. Okay, no issues. D by dx of this thing is equal to what? Functional limit. Please see. This is limit delta x tends to 0. Okay, and what? Mod x plus delta x minus delta minus x upon delta x. This is what you have to do. Now, if you had to find it at, if your x is 0, then x is 0, then this will become what? Limit delta x tends to 0. At place of x you put 0 plus delta x mod minus x is 0. Okay, upon delta x. Okay. So this is what, now please see to it. This is now limit delta x tends to 0 and what else? This is mod delta x minus mod of 0. Mod 0 is how much? 0 upon delta x. Delta x. So this is basically limit delta x tends to 0 mod of delta x upon delta x. Okay. Now see. Here let us see, let us take 0 plus. 0 plus mod delta x will be what? It will be see positive only. So if on the right side we are going, everything is plus, so no issue. It is delta x upon delta x, so the value will be plus 1. And let us calculate what is if delta x tends to 0. Left hand limit, let us calculate it. So what it will be? Mod delta x here will be what? Minus delta x, because as soon as you are on the left side, this modulus of delta x will be what? Negative number. So negative, if you want to make positive, you have to multiply with the minus sign and minus x. Because on the negative side, how this modulus x is defined? Minus x. So it will be minus delta x upon delta x, so it is minus 1. See, left hand limit is not equal to right hand limit. Left hand limit is not equal to right hand limit, and as such the question of this thing, derivative to exist doesn't arise, because this limit has to exist. This limit has to exist. This limit at 0, this limit has to exist. In order this limit should exist, what should happen? Both left hand limit and right hand limit should be equal. Whereas one way it is plus 1, other way it is minus 1 also. And this is the mathematical proof through your this definition. But if you make use of this thing, as I have told you that what this thing gives you, modulus, it gives you the slope of a tangent drawn at that particular point. Now see here, if you are drawing on a straight line, please see, on a straight line, what is the tangent? The line itself. At any point of a straight line, suppose this is the point, you take Q, you bring PQ and join PQ, and then the line corresponding to PQ is what? The same line. Howsoever nearer you can bring. So on a straight line you take a point, and if somebody asks you what is the tangent, therein the line itself will be the tangent. The line itself is the tangent. And the slope of this tangent is what? Tangent 45. This is 45 degree. So tangent 45 is 1. And what is the slope of this thing? It is tangent 90 plus 45. So it is minus 1. So both ways you can, and this is what you are getting. Derivative is giving you plus 1 when you are on the right side, and it is giving you minus 1 because it gives you essentially the slope of the tangent drawn there at the point. So at 0, if you are taking on the right side, points are being taken on the right side, right hand limit, then it is plus 1 and then it is minus 1. So this is the basic theorem, and this is what you are going to make use of in attempting the question number 9 here. Yes, let me do it. Now you can take this question 9 very easily. Only you have to remove it. It is fx is equal to mod x minus 1. Fx is equal to mod x minus 1. X is the element of, is not differentiable at x is equal to 1. What is non-differentiable is not differentiable at x is equal to 1. Okay, simple it is. You can always convert it. One way, if see it is mod t. What I will do, I will put t is equal to x minus 1. Okay, so here if you are putting it, it is modulus PC. Okay, so what effectively you are getting here, in terms of x, it is differentiable at x is equal to 1. So you put here, so for here, differentiability will have to be checked wherein? At 1 minus 1, at t is equal to 0. So what you have to show, now your question, this question can be reframed as if ft is equal to is not differentiable at t is equal to 0, and this is what we have just now done it. And this is what we have just now done it. So the proof is complete. So the proof is complete. Okay. This is what we need to do it. But if in examination it is asked, then what you can, the second method which you can employ for doing it could be like this. That you change your function. You change your function. That x mod x minus 1. Okay. Somebody constant. Okay. Fx is equal to mod x minus 1. Please see, this is 0, this is 1. Okay, and x is equal to 1. Okay, fine it is. So now see, if x is lying between here 1, if x is less than 1, this thing, if x is less than 1, then what will happen? X minus 1 will be negative. X minus 1 will be negative. So fx will be what? In order to make it positive, x minus 1 when x is less than 1 or equal to 1. And this will be equal to what? X minus 1 when x is greater than 1. Because when it is greater than 1, it is always positive. So this function you can define this particular manner also. This is how you can define it. And then see, so what it is? It is minus x plus 1. So minus x plus 1 you can then write to be what? 1 minus x also. Now see, you at 1 you have to show it. So limit x f1 plus h minus f1 upon h, that is doing h tending to 0, 1, h tending to 0 plus. Okay. Now you are on the right side of 1. Then let us put this, see whether what is this limit here. f1 plus h. 1 plus h means what? You are greater than 1, so it will be x minus 1. It will be how it will be x minus 1. So at place of x, what you will put? 1 plus h. So it will be h. 1 plus h minus 1 minus f1. It will be 0 upon h. Okay, upon h. So this is plus 1. This is plus 1. H cancels. And let us find this right hand, left hand limit s tending to 0 minus, yes, fh, this thing, yes, 1 plus h minus f1. So when h is negative, see, h is taking a negative value, so 1 plus h will be on the left side of 1. On the left side of 1 means it is 1 minus x. 1 minus x. X means 1 plus h. Minus f1. F1 is what? 0. 1 minus x. At place of x you will put 1 minus 1 0 upon h. So it is minus h upon x. So this is minus 1. So both left hand limit, right hand limits are different. As such, the function is not differentiable as equal to 1. So either way you can do it. Either way you can do it. Now see, I am short of time. Okay, I stop it here. I will not text you too much, but I really wish to take up this implicit function, but I will take it on my next article. Today, my request to all of you is that please try all the questions on the composite function away from the book as well. Okay, thank you.